Welcome to The Explainer. Okay, let's talk about intelligent automation. You hear that term everywhere, but what does it actually mean? We're going to cut through all the jargon today. In fact, we're going to build our own digital worker from the ground up just to show you exactly how this stuff really works.
So, let me ask you something. When I say the word automation, what's the very first image that pops into your head? For most of us, I'm willing to bet it's something pretty specific. You're probably picturing giant robotic arms, right? Conveyor belts, maybe a car factory whirring away. And that makes perfect sense. I mean, we humans have been automating things since our ancestors first picked up a rock and made a stone axe. We've always been finding ways to make physical work easier. But here's the thing. The most revolutionary automation happening right now, it isn't about moving heavy objects at all. It's built from completely different stuff. It really all boils down to a fundamental distinction. You see, there are two basic kinds of automation.
On one side, you've got physical automation. That's all hardware, the robots, the gears, the machines moving things around in the real world. But on the other side, you have what we're talking about today, intelligent automation. And this is pure software. Its job isn't to move things in the physical world, but to move and process information in the digital world.
Okay, so here's the challenge, right? This software-based automation, it can feel kind of abstract. It's not a big metal arm you can see and touch. So how in the world do we get our heads around what it is and what it actually does?
Well, it turns out there's a brilliantly simple way to look at it. We can understand this whole complex world using something called the human blueprint. And the idea here is powerful because it's so simple. Instead of getting totally lost in confusing code and algorithms, we can understand intelligent automation by comparing its skills to, well, the ones you and I use every single day. So, using this human model as our guide, we're going to build a digital worker. And we're going to give it 4 core capabilities, 4 building blocks that actually mirror our own: vision, execution, language, and finally, thinking and learning. All right, first things first. Before our digital worker can do a single thing, it needs to be able to see. We need to give it eyes. In the tech world, we call this computer vision. It's pretty much what it sounds like. Just like our eyes can see a stop sign and know what it means, computer vision lets software perceive and understand its digital environment to see the buttons, the text fields, and all the images on a screen and actually know what they are. And we're not just talking about basic sight here. I mean, think about a self-driving car. Its vision system doesn't just see a blob of pixels. It knows, in a split second, if that object is a traffic sign, a truck, or a person. That's the incredible level of perception we can give to our digital worker. Okay, so our worker can see. That's a great start. The next logical step, then, is to give it hands so it can actually interact with that world it's seeing.
So in a factory, the doing part is obvious. It's robotic arms putting car parts together. But in the digital world, the doing part, what we call execution, is stuff like typing information into a form, clicking a drop-down menu, or copy-pasting data from a spreadsheet into some other application.
And listen, I know those actions sound really simple, maybe even trivial, but that's precisely what makes them so valuable. Think of them as the basic square Lego bricks. They make up the bulk of the work, and they are the absolute fundamental components for getting just about any digital task done.
So our worker has eyes to see and hands to do. But to be truly useful, it needs to be able to understand us and communicate back. It needs a voice.
Now let me tell you, getting a computer to understand human language is incredibly hard. It's not clean, perfect machine code. It's messy. We have accents and dialects and slang. We use intonation and sarcasm to completely change the meaning of a sentence. This is where technologies like natural language processing come into play. They're designed to bridge that messy human gap and figure out what we actually mean. And that brings us to the final and maybe the most powerful building block of them all. We've given our worker eyes, hands, and a voice. Now let's give it a brain. Okay, this is a super important point. Despite what you might see in the movies, this capability isn't about replacing the human brain. Not at all. It's about augmenting our own abilities. It helps us analyze, predict, and make decisions by handling the parts of the thinking process that computers are just plain better at. And this is the perfect way to think about it. Imagine you're back in school, tackling a really tough math problem. You couldn't just type the whole thing into your calculator and get the answer. The calculator was a tool, right? It handled the tedious number crunching, and that freed up your brain to do the actual critical thinking, figuring out the steps and putting it all together. That's exactly how these learning technologies work with us. So, there you have it. We've done it. By combining these 4 human-like capabilities, vision, execution, language, and learning, we've assembled a complete digital worker. It's a tool that can see, act, understand, and even analyze, all inside the digital world. So we have the blueprint. We know how to build this new digital workforce. The technology itself is no longer the barrier. So the only real question left for us is, the most important one, what big, meaningful problems are we going to choose to solve with it?